Hi, I'm Pat Kelly. All right, in this problem, we're given this probability density function of f of x equals 1/3 over the interval from 0 to 3. They ask us to find the expected value, the variance, the standard deviation, and then when we're done, to draw a graph of the function and to plot the mean. So we'll begin by finding the expected value, or the mean. And really for any of these types of calculations, I'd probably start with the formula. Make sure you know what formula to use and make sure you would know how to use the formula. So the formula for expected value, or the mean, is the integral from a to b of x, f of x, dx. That's the formula for expected value. And so for this particular problem, our limits of integration will be 0 and 3. X, and then our f of x is the 1/3. So to get our answer for this, it's really just going to come down to evaluating that integral. To evaluate this integral, I'd probably bring that 1/3 out, any constant factor inside of an integral, and then evaluate that definite integral, which is going to be x squared over 2 from 0 to 3. And now we're just plugging in the limits of integration and doing a little bit of arithmetic. 3 squared is 9, still divided by 2, and then subtract 0. And to evaluate this, then I get 3/2. So my answer for the expected value, or the mean, is 3/2. Second part of the problem is to find variance. And they do specify in our directions to use the alternative formula. Again, begin with the formula. Make sure you know what formula to use. And in this case, the alternative formula for variance is the integral from a to b, x squared, f of x, dx. And then after the interval, outside of the interval, subtract mu squared. Now you apply the particulars for this problem to this formula. So again, our limits of integration are going to be 0 and 3 from our endpoints of the interval. X squared and our f of x is 1/3 minus mu squared, and our mu is 3/2. So 3/2 squared. And then evaluate the integral to get our variance. Bring the 1/3 out again, 0 to 3, x squared dx. In this step, I'll go ahead and square the 3/2, 9/4. Evaluating the integral, x cubed over 3 from 0 to 3. I do still have the minus 9/4. You don't want to let that go. Evaluating 3 cubed 27 divided by 3 is 9, subtract 0. So we're going to get 1/3 times 9 is 3, subtract 0, minus 9/4. A little bit of arithmetic. I'll just get the common denominator of 4, 12/4 equals, equals 3/4. As a decimal, 0.75. Okay, so we have our answer for variance. And I put it in a decimal form there because our last part of the problem for evaluating is finding the standard deviation, which again, I'd start with a formula, but the formula for standard deviation is the square root of the variance. So I'm just going to take that 0.75 and put it under the square root. And for that, you grab a calculator if you want. So we would be looking for the square root of 0.75, approximately equal to 0.866. So the problem gave us that probability density function. We found the expected value, the variance, and the standard deviation. The last part of the problem asks us to graph the function. So I'm going to graph a constant function, f of x equals 1/3. And so I'm just going to end up with a nice horizontal line over the interval from 0 to 3. So I really only even have that part of the x-axis. So that would be a graph of the probability density function. They also mentioned to plot your mean. So our mean is 3/2, which would be right there. U equals 3/2. And the mean, also called the expected value, you see in this particular problem, that mean is really where you'd expect it to be. This is a uniform distribution, and so the middle of the uniform distribution is right between 0 and 3/2. So the expected value is really what we would expect. Okay? Final answer, though, for mean is 3/2. Variance 0.75, standard deviation 0.866. Okay, hopefully that helps. Thanks.